Newton's second law states that acceleration is based upon force applied to the object and the mass of the object. A change in force or mass will change the object's acceleration. This law can be summed by the formula F equals ma, or force equals mass times acceleration.
To do this experiment, you will need the materials a mass scale or balance. You'll need a ruler. You'll need one heavy golf ball, one light golf ball, one or two spring scales, and a blank piece of paper. The first thing we're going to do is we are going to weigh the mass of the golf balls. So we're going to take our scale. We're going to take the heavy golf ball and put it on. And you're going to record on your paper that it is 46 grams. Okay, now we're going to do the light golf ball. It's back at 0. The light golf ball is only 4 grams. So that means the heavier mass one is 10 times more massive than the light one. We take the ruler and we put it on the piece of paper and we draw our starting line. And see, there is our starting line. So when we put the ruler down, it will go on to the starting line. Then we decide one end to be our anchor and one end to be the side that we pull back. The anchor end needs to stay on the starting line and the anchor end will get pulled back. We'll use our spring scale that has newtons. It has an N right there that stands for newtons. And 5 newtons is if we pull it back. If I pull on it, that is, see, that's 0. So that's 5 newtons. So we're going to use that to figure out how much 5 newtons is on our ruler. We pull it back till the spring scale reads 5 newtons. So then you can see where 5 is, and if I had a partner, they would mark it while I'm holding it. But since I don't have a partner, I'm just going to remember that right there is 5 newtons. And I'm going to mark that 5 newtons. Okay? So now I can put the spring scale away because I know that anytime I pull the ruler back to there, that's a force of 5 newtons. So then I'm going to put one of my golf balls. Your lab procedure says you need to start by using the light ball. So I've got my 2. This is my light one. And I'm going to put it right at the edge there. And I'm going to hold my ruler at a 5 Newton angle. And I'm going to let it go and see how far it goes. After I record my results, I'm going to do the same thing with my heavy golf ball. I'll put the heavy golf ball down. And I'll bend my ruler back to 5 newtons and see how fast it goes. Which one went faster, the heavier or the lighter? Now we're doing the low mass ball, okay? Okay, low mass ball at 4 newtons. Ready? Ready, set, go. Stop. Okay, what did you get?
126.
Okay, 126. 0.7. 92. Okay, so let's meet in the middle. We'll say 0.9 for that one. 0.9. Okay? Everybody, that means you're going to take in your chart. You're going to say low mass, 4 newtons, time 0.9 seconds. Everybody writing that down?
Wait, what's the time? Does Heath, what's the time?
0.9 seconds. 0.9. Okay, now we're going to switch to the heavy mass ball. Okay, this is the high mass ball. Okay, we are also doing this one at 4 newtons. Ready, set, go. Stop. Let's do 213. Let's do like 1.8 is kind of an average of those ones. 1.8. So now you're going to say high mass, 4 newtons, time 1.8. Now we're going to up the newtons. Now we're going to do heavy mass, 6 newtons. go. 0.6. Ready, set, go. Stop. Let's do 1.2. 1.2 is about an average, okay? 1.2 for high mass is 6 newtons. Okay, now we're doing 8 newtons. Ready, set, go. Stop. Do 0.9 for that one. 0.9. Okay, now we're going to do 8 newtons. 0.7. 0.7. 8 newtons. Ready? On your mark, get set, go. Stop. 0.8. We're going to go with 0.8. You should be writing 0.8 seconds on your chart. Okay, now we're doing 10 newtons. I'm going to break the ruler on this one. All right, are my timers ready? Okay, ready, set, go. Stop. Or 0.7?
97.
97?
We actually did 2 experiments here, one where we changed the mass and one where we changed the force. For the first one where we changed the mass, we're going to show on our bar graph that the low mass ball took 0.9 seconds to get to the stopping point, and it took the high mass ball 1.8 seconds to get to the stopping point. Go ahead and pause the video and fill in your graph. For the second experiment, we kept the mass the same. We used the high mass ball, but we changed the amount of force. So on your graph, you're going to put a data point for when we used 4 newtons in the high mass ball. It took 1.8 seconds for the ball to reach the end. For 6 newtons, it took the ball 1.2 seconds to reach the end. When we changed the force to 8 newtons, it took 0.8 seconds for the ball to meet the end. And when we used 10 newtons, it took the ball 7 seconds to get to the end of the line. Once we have all those data points plotted, then we're going to draw a line that shows the trend. As you can see, the higher the force we used, the less time it took for the ball to get to the end.